We're going to talk about our second classifier today. Last lecture was, last two lectures, we talked about naive Bayes. Today we're going to talk about decision trees. A very, very different kind of a classifier, works in a totally different way, produces decision boundaries that are nothing like naive Bayes decision boundaries, and has some really cool properties about it. So I find the best way to learn about decision trees is to start working through an example. So suppose we're building a decision tree to classify if our friend John is going to play tennis on any given day. So we've collected some observations. We've watched John for 2 weeks, and he played tennis on 9 days out of those 2 weeks and didn't play tennis on 5 days. And the things that we observed is we observed whether he played or not, and we also looked at the weather. So was it sunny or was it rainy? Was it humid? Was it windy? And we are suspecting that those attributes have some influence on whether John decides to play tennis or not on a given day. So what we want to do is we want to look at these training examples and somehow from them learn whether John is going to play tennis or not. And of course, we're going to use it for predicting, right? So on day 15, suppose it's rainy and the humidity is high, but it's not very windy. So would John play in this kind of weather or not? Is he more likely to play or not? And of course, if you look at this, you'll realize, well, there is this combination of weather hasn't actually occurred in the past. We've had rainy days with high humidity, but we didn't have a rainy day with a high humidity and no wind. So does that matter or not? We don't know. So just from looking at it, predicting whether John is going to play or not is not terribly straightforward. Question?
Isn't D4, isn't it?
I'm sorry?
Isn't D4 the same?
I can't hear you.
D4 is the same.
Oh yes, thank you. I stand corrected. So D4 is actually the same as D15, so you could just look it up. And that's what our next classifier will do. In the next lecture, we're going to talk about nearest neighbors classifier, right? And that's what the nearest neighbor classifier will do. But a decision tree is going to try to do it in a slightly different way. So what the decision tree is going to try to do is it's going to look at these factors and try to figure out how the individual attributes, how the individual factors affect the chance of John playing or not playing tennis. And it works in a kind of a divide and conquer fashion. So what we're going to do is we're going to take our training data set, pick one of the attributes, and use this attribute to split up the training data set into a bunch of little training data sets. Right? So maybe what we'll do is we'll take Outlook. Outlook, it's either sunny or overcast or rainy. So we'll split up our data set into 3 subsets and then look, does John play consistently or consistently not play in each one of those subsets? And if we find a subset where John always plays or always doesn't play, we make a conclusion that that value of the attribute leads to John playing or not playing. Right. And if the subsets are not pure, if the John both plays and not plays within a subset, we're going to repeat the process. We're going to take this now smaller subset and use a different attribute to split it. And we're going to keep splitting the data until there is no uncertainty about whether John plays or doesn't play. And then when we have a new data point, of course, we'll look into which of those subsets the new data point falls, and from that read off whether John is going to play or not.